Okay, so this is where we're going to start 12-1 angles of triangles. Last class we went over all the different types of angles, acute, right, obtuse. We started talking about the different types of triangles. And we said we can classify triangles by their sides using scalene if they don't have any congruent sides, isosceles if they have two congruent sides, at least two, and equilateral if they have three congruent sides. So that's one way to classify them. We can also classify them by their angles. If they have three acute angles, it's going to be an acute triangle. If it has a right angle, it's a right triangle. If it has an obtuse angle, it's an obtuse triangle. And then if they're all the same, it's equiangular. Equi for equal, angular for angle, so equal angles. And do you know what all of those angles are? You know what each one of those? They're all acute. And if the whole thing is 180 degrees, what's each one of them? Oh. You know what the number is going to be? So we have 180 for all of them. We divide by 3, 60. So each one of those angles is going to be a 60-degree angle, all right? So if we wanted to classify this triangle, how many sides does it have the same? 2, so it's an isosceles triangle. And then if we classify it by its angles, what do you notice about those angles? They're all acute. So this is an acute isosceles triangle. We can name it both ways. Okay, we're not going to practice those. Let's start here. Okay, triangle ABC has vertices 0, 0, 3, 3, and negative 3, 3. This one's not in your notes. This one's one you just watch. And then the next one I'll let you practice. So we want to classify the triangle by its sides. So we need to know how long the sides are. Does it tell us how long the sides are? No, it just tells us what the endpoints are. So we can use the distance formula for that. So you may want to write this one down. Distance is equal to, this is a formula you learned last year. x2 minus x1 squared plus y2 minus y1 squared. This is actually a theorem that comes from the Pythagorean theorem. A squared plus b squared equals c squared. You can see the squareds and the plus in there.
We could use calculators.
You can, but I think it's actually a lot easier if you don't. As long as the numbers don't get too ugly, I think it's a little bit easier to do it by hand, but I'm not going to say don't use them. Okay. So if we want to find the length, so we have this triangle ABC, right? A, B, C, and we want to find all of those side lengths. So to find the length of AB, we're going to use point A and point B. One of them needs to be x1 and y1, and one of them needs to be x2 and y2. So I'm just going to pick, this one's going to be my 1, this one's going to be my 2. It's not going to matter which way you pick it, okay? So to find AB, this is the length of AB, so I put a little line above it. It's going to be the square root of those two things squared and these two things squared. So x2 is going to be 3, and x1 is 0, so 3 minus 0. And then here's y2 and y1. Remember, they're always x, comma, y. So this one is also
3 minus.
Right, so now we do parentheses first, write our grouping symbols first. So 3 minus 0, 3 squared, plus 3 minus 0.
3.
Now we do our exponents. What's 3 squared?
9.
9, because it means 3 times 3. So 9 plus 9, 18. Is 18 a perfect square?
No.
No. So we're just going to leave it the square root of 18. We're not even going to change it to a decimal. It's going to be easier to leave it just like that. So that's the length of AB, the square root of 18. Square root of 18 is somewhere between 4 and 5, if you want to have an idea of how long it is. Okay, now let's find the length of BC. Is it okay if I write it here?
Yeah.
Okay. It's gonna get a little bit messy. The square root of, now I need to pick 1 and 2 again. Since I already had this one being 0.2, let's make this one 0.1. You know what I mean?
Yes.
Okay. So what is x2?
3.
3. What is x1? That's from this one. Negative 3. So 3 minus negative 3 squared plus y2,
3.
y1.
For the 3 minus negative 3, couldn't you change it to 3 plus 3?
Perfect. Let's go ahead and do that. 3 plus 3. Yes.
You know how you did your 1, 2, and 1?
Mhm.
Does it matter? Like
No.
what? So you could do any of them?
Yes.
2, okay.
Yes.
But
It's just important. If this is x1, if this is x2, this has to be y2.
you just have to have 1, 2.
Oh, well, we're going to do AC in a minute.
Okay.
One of those is going to need to be 2. So 3 plus 3, 6 squared plus, you see what I mean by this is a lot easier without the calculator? So that 6 squared is that a perfect square?
Yes.
Yes, so that's 6. So we know we have one side length that's the square root of 18 and one that is 6. And now we need to find our last one. So we're going to use point A and point C. Let's see. Okay, so now we shrunk those and moved them over so we had a little bit more space to work. And we need to use AC. So I'm going to rewrite. A is 0, 0, and C is negative 3, 3. So to find AC, we're going to do, let's see. Let's do this to be 1 and this to be 2. That way we can subtract the zeros. Okay? Squared plus squared. Sometimes I like to draw that in blank and then fill in the numbers. So x2 minus x1, y2 minus, if it helps you, and it may, write xy and xy underneath those. Anything that helps you. So let's see, what's negative 3 minus 0? Now, this is something I want you to be careful with. When you do negative 3 squared, it has to look like that. Don't just write negative 3 squared. And I'll tell you why in a minute. Plus 3 minus 0 is 3 squared. Negative 3 squared means negative 3 times negative 3. So a negative times a negative is a positive, and 3 times 3 is 9. So that's 9. That's 9.
18.
Square root of 18. Oh, so how many sides do we have that are the square root of 18? 2. So what kind of a triangle is it? Isosceles, because it has 2 sides the same. So we already know that. That's the first part of it. Classify it by its sides. But the second part asks a trickier question. Is it a right triangle? And last year you learned something that worked only with right triangles. And that was a theorem I just mentioned a second ago. The Pythagorean theorem only works with right triangles. And the Pythagorean theorem says a squared plus b squared equals
C squared.
And since it only works for right triangles, if it works for this triangle, it must be a right triangle. So what we're going to do is plug in our side lengths into this equation and see if it works. Now, we need to know which one is C. So in the right triangle, C stands for which side?
The one that isn't. Oh, wait.
C's the
long one.
The long one. C is the hypotenuse. So what's the longest? The square root of 18 or 6? 6. So we're going to say this is our A, this is our B, and this is our C. A and B, it's not important which is which, but C has to be the longest side. So I'm going to take these numbers and substitute them into our formula. A is what? Square root of 18, and we need to square that, plus the square root of 18 squared. Well, what is 6 squared? 36. Square root of 18 squared means the square root of 18 times the square root of 18, which is 18. And it might be easier if you think about it with a smaller one, like the square root of 3 times the square root of 3 is the square root of, what's 3 times 3?
9.
What's the square root of 9?
3.
3. So when I do the square root of 18 times the square root of 18, I get the square root of, I don't remember what 18 times 18 is, it goes there, which would just give me 18. Okay, so
whenever you have a square root, it's
yeah, if you square it, you just get the number underneath.
But only by 2.
Yes, only if you square it, not if you do anything else to it.
Oh.
So what's 18 plus 18?
36.
So is this true?
Whoa.
Because it's true, it is a right triangle.
What?
So it's isosceles, our final answer is it's isosceles, and it's a right triangle. So I'm going to have you do problem in your notes packet. You're going to do problem number 4. And it says classify ABC by its sides and then determine whether it's a right triangle. And the order pairs are 6, 6, 9, 3, and 2, 2. Okay, so for number 4 in the packet, we found that we had the sides the square root of 18, the square root of 32, and the square root of 50 were our 3 sides. Those were the lengths of our 3 sides, right?
Yeah.
And we said that means it's a scalene triangle because all 3 sides are different in measure. And then we used the Pythagorean theorem to test to see if it was a right triangle. So we had the square root of 18 squared plus the square root of 32 squared equals the square root of 50 squared. So 18 plus 32 equal to 50?
Yes.
Yes. So since that's true, it's also a right triangle.